Free from jctuition.net, and today we're going to be talking about small angle approximations. By the end of the video, I'm going to prove to you that for small values of theta, so theta small and measured in radians, well, it follows that sine theta is approximately theta. I'll also show you that cos theta is approximately 1 minus a half theta squared, and finally that tan theta is also approximately just theta. The approximation is that sine theta is approximately theta. Can I prove this? Well, let's consider the graph of sine x and y equals sine x, and let's just say we drew also the line of y equals x. It's not the straightest of lines, but that'll do. So that's y equals x. Hopefully you can see that as long as we're sort of near the origin, that sine x, the graph of y equals sine x, is actually approximately the line y equals x. Obviously, as we go away from the origin, that becomes less true, but as long as our value of x is small and we're close to the origin, it does stand true that it's almost approximately equal to the line y equals x. So we can actually say that the small angles of x, sine x, is approximately x. I mean, this hardly counts as a proof in the mathematical world, so I will attempt to prove it in a proper way. So let's consider this sector, and we split up with a line. We call this line AB, and it has the length, the radius, just r, and an angle theta. Well, hopefully you know how to work out the area of a sector. So what we do is we say it's well, the area of a sector for the sector is a half times r squared. Take both radiuses, and then we multiply it by theta. Should be familiar with that. And to work out the area of a triangle, should be familiar with that. Draw a little triangle. Should be familiar with that. It's half multiplied both the sides, so r squared, and then sine of the angle wedged in between. So that's sine theta. Alright. So now I want you to imagine what would happen if theta was really small. What would happen if this angle was really, really small? Let's almost try and visualize that. Well, if this angle gets smaller and smaller, well, then suddenly this line AB is more like this. It's my triangle now. So hopefully you can appreciate that as theta gets really, really small, shown by the dotted lines, that the line AB gets very close and close to the sector line, the arc of the sector. So it follows that when theta is really small, the area of the sector is approximately equal to the area of the triangle. So we can say that half r squared, therefore theta is approximately actually the same as the area of the triangle. So therefore it follows that what we've done here is we've just literally replaced theta with sine theta, so they must be equal to each other. So therefore, as long as theta is small, sine theta must be approximately theta. Okay, do the same thing for cosine. So it doesn't follow that if I draw a line y equals x, that cosine is anything like it, or can be used. The line can be used as an approximation, not at all. But if I look at this, it does sort of look like a negative parabola, especially when it's closer to the origin. So I suspect we can use, as long as x is small, we can use something to approximate cos x. I assume because it crosses at 1 on the y-axis, it'd be 1 minus x squared or something similar. I mean, I did tell you at the start already what it is. It's 1 minus a half theta squared. So let's see if we can go about proving this. So again, if we have our triangle area, if we have a sector with AB being the length of the line and the sector, and both sides r, and we'll label the angle theta. Well, this time instead of going for area, let's consider the length of the line and the arc. So let's look at the length of the arc. Well, you should be familiar with this. It's just the radius times the angle, so it's just r theta. And the length of the line, well, we can use the cosine rule here, where we can say, so the length of the line squared, so AB squared, is equal to, we can add both sides squared, so r squared plus r squared minus 2 multiplied by each of the sides, so r squared again, r times r, and cosine of the angle that's wedged in between. So that's the cosine rule. Well, again, if theta is really, 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 really small, we saw that the length of the line is actually almost the length of the arc as well. So it follows that. So it follows that for AB squared is, well, we collect these terms, so it's 2r squared minus 2r squared cos theta is approximately r theta squared, because the length of AB is now squared. And we can actually factor out r here, r squared even, and expand on the left, so that becomes r squared theta squared. And we've got that r squared is 2 minus 2 cos theta is approximately r squared theta squared. And these r squareds cancelled out. So we're left with 2 minus 2 cos theta is approximately theta squared. And rearranging this, we get that 2 cos theta is approximately 2 minus theta squared, and divided by 2, we get that cos theta is approximately 1 minus a half theta squared. Okay, so you can do the same sort of thing with tan theta, and I encourage you to have a go. So again, to summarize, as long as theta is small, measured in radians, we find that sine theta is approximately theta. We're given that cos theta is approximately 1 minus a half theta squared. And you can also work out in the same sort of way that tan theta is approximately also theta. So can we use real numbers and sort of try and prove this? Well, let's use cos 0.4 radians. 0.4 is small, so let's try and approximate. So let's say cos 0.4 is approximately then 1 minus a half of the angle squared, so 0.4 squared. So that's of course 1 minus 0.16 over 2, and if you plug that into your calculator, you get 0.92. Okay, and so let's try and work out the percentage error. How far off is it from the actual value of cos 0.4? So I'm just writing into my calculator now, and cos 0.4 is actually, yeah, it's 0.921060994, etc. So how far off is that? Well, you can use percentage error. So let's say cos 0.4, take 0.9. We'll modulate it to make sure we get the positive answer, divided by the actual value, which is cos 0.4. Plugging that into my calculator, we get 0.115%. So not too bad of an approximation. So I hope small angle approximations make sense to you now. If you would like more maths resources, please do visit www.jctuition.net.